Hi there. Have you noticed that WRO competitions don't seem to have as many lines to follow as they used to? You need to be able to move the robot around without line following. In this video, I will explain how you can use the SpikePrime internal gyro sensor and keep the original yaw setting, which is set to 0 at the start of the program. I will look at the limitations of the gyro accuracy and show what you can do about it. I will also show what possibilities you have to position the robot accurately without line following. I have made a simple robot to use in the video. It uses 2 of the hub ports for the drive motors and the remaining 4 ports for light or color sensors. A normal competition robot would have only 1 or 2 color sensors, but I have used 4 here just to demonstrate the possibilities. There is a color sensor at each side of the robot which can be used to look for colored objects. On the underside, there is a sensor at the front and at the back. These could be used for line following, but here I will use them to sense when a black line or another color has been reached. The robot is programmed to drive around the WRO 2025 senior course and pause and beep each time the position or direction is fixed. Line following is not used at all. The idea is to end up accurately positioned next to the square multicolored block. Let's look at this in more detail. The yaw is set to 0 at the program start, and the robot moves until it sees the black line. It then reverses into the wall and zeroes the yaw. It turns anti-clockwise and then clockwise, then moves until it sees the yellow area. It moves until the side sensor sees the green marker. The robot then turns twice and moves up to the red marker. I will explain later why we cannot use the yaw sensor for this turn. We now reverse into the wall, zero the yaw and drive up to the yellow marker followed by the blue marker. The robot then moves until it sees the black line. It turns 90 degrees clockwise and then drives up to the side wall where it zeroes the yaw. It reverses and turns and moves till the sensor does not see the color white. It then drives the short distance to the end point. Now, how does this work? The key to navigating around like this is a variable we define as yaw target. This is set to 0 at the program start and used by the proportional yaw follower MyBlock to move around. As the yaw sensor value is automatically set to 0 at the program start, the robot will move straight ahead. To turn, for example, through 90 degrees, we use a turn MyBlock, which first changes the yaw target variable by 90 degrees and then turns until the yaw sensor value reaches the new yaw target. We can then move ahead in the new direction. To summarize, yaw target sets the yaw direction for the yaw follower. The turn MyBlock changes the yaw target by the required angle and turns the robot. The yaw follower then moves in the new direction. Even if the turn angle is not correct, the robot will move in the right direction after the turn. I will explain the MyBlocks used in more detail later. Now I want to mention the gyro accuracy. Unfortunately, there are errors which accumulate after a few turns. If the robot turns through 360 degrees, there will be an error of 1 to 2 degrees, or more if the motion is fast or jerky. To solve this problem, you can drive into a side wall to align with the mat and set the yaw sensor to 0. There is also a problem with a yaw sensor value of plus or minus 180 degrees. The value flips from plus 180 to minus 180, which makes it impossible to use a yaw follower or turn MyBlock. I am working on a solution to this, but for this video I will avoid moving with 180 degrees yaw. This is why I used a simple turn function at one point before doing a yaw 0. If we look at the line graph for the whole run, we see the yaw sensor flips from plus 180 to minus 180 degrees before the second yaw 0. This makes it impossible to turn using the yaw sensor. Now let's have a look at the main MyBlocks used, starting with yaw distance. This moves the robot with speed MP in percent for a distance in centimeters, so it has two parameters as shown. We stay in the loop until the specified distance has been traveled. Inside the loop, we have a proportional yaw follower. The difference between the yaw sensor and the yaw target is calculated, multiplied by the factor kp yaw, and then used to make the difference equal to 0. The value of kp yaw is adjusted for optimal performance. The MyBlock yaw ramp distance is the same as yaw distance, but with a speed ramp. The speed changes from MP1 to MP2 over the distance specified in centimeters. This can be used to accelerate or decelerate and works forwards or in reverse. The MyBlock yaw ramp color dist is similar to yaw ramp distance, but stops when the specified color is seen by the color sensor on the underside. Parameter offset then moves further if required by the specified distance in centimeters. For the color parameter, the LEGO color code is used as shown. The MyBlock yaw color found is similar to yaw distance, but moves at a fixed speed until a color is found. It remains in a repeat until loop till the color code seen is not -1. -1 is the code given by the sensor when no particular color is seen. Parameter offset defines an additional distance to move if required. The MyBlock yaw no color D moves until sensor D underneath the robot sees the color code -1 for no color. This was required when leaving the square with the dark blue border, as dark blue was not recognized by the sensor. The offset parameter adds a specified distance as for the other MyBlocks. Finally, we come to the turn universal MyBlock. It would of course be possible to use a simple turning MyBlock. All it has to do is change your target by the angle to be turned, and then turn until the new yaw target has been reached. Turn universal has 4 parameters. MP max is the maximum speed used at the midpoint of the turn. MP min is the speed at the start and end of the turn. Angle is the angle to turn, positive for clockwise, negative for anti-clockwise. %MP defines what percent of the faster wheel speed is applied to the slower wheel. With %MP at 0, the robot will pivot on one wheel. With -100%, the robot spins about its midpoint. With a larger value, for example 50%, the turn radius becomes larger. Parameters MP max and MP min can be used to optimize the speed and overshoot of the turn. MP min sets the speed at the beginning and end. MP max sets the faster speed in the middle. Here you see the turn block in more detail. The first part calculates some values for the second part. The second part calculates the motor power depending on the angle turned. The third part drives the motors in the direction required to carry out the turn. Well, I hope you found that useful. Moving around without line following is definitely more in demand. Let me know if you have any other ideas on how to do this. This playlist has information on other SpikePrime topics which you may find interesting. Please like and subscribe. See you in the next video.